We'll continue here. Sorry for the interruption. So compound of source is all water pipes, all pins in some kind of racing cars and from very old engines. The first effect of lead is it can cause significant damage to the central nervous system. Young infants are particularly susceptible to lead poisoning. So you must remember, compound of lead is not a kind of gas, so it may not affect our respiratory system. Okay. Tips. Complete and incomplete combustion of hydrocarbon produces different products. Complete combustion occurs in oxygen and produces carbon dioxide and water, while incomplete combustion occurs in oxygen deficient conditions and produces carbon monoxide, water, and sometimes carbon. Nitrogen oxide engine, okay, nitrogen oxide, which is nitrogen monoxide and nitrogen dioxide, form when nitrogen and oxygen react in the high pressure and temperature. So remember to condition high pressure and temperature conditions of internal combustion engines and blast furnace. Exhaust gas also contain unburned hydrocarbon and carbon monoxide. Cars are fitted with catalytic converters which form a part of their exhaust system. So next we are going to see the function of the catalytic converters. Okay, here is the diagram of the catalytic converters. You can see here actually the function of the catalytic converters is to convert poison gas like carbon monoxide and nitrogen monoxide into carbonous nitrogen gas, while oxygen, as it is not an unpolluted gas, so it remains as oxygen gas. Okay, the inside of the catalytic converter there are a series of transition metal catalysts which include platinum and rhodium. So here is the honeycomb structure, and why the structure in honeycomb base is to increase the surface area for the reaction to occur. It will increase the rate of reaction of the catalytic converter. Okay. Here it says that a series of redox reactions. So what is redox reaction? Actually, oxidation and reduction reaction occurs simultaneously. Okay. Occurs at the same time and the same reaction. Okay. The rusting of iron. Okay, rust is a chemical reaction between iron, water, and oxygen to form the compound iron. Okay, rusting is actually special for iron metal only. Okay, for the other metals, like copper, aluminium, zinc, and etc., we don't call it as a rust, but we call it as a corrosion. Okay, so in the rusting process, oxygen and water must be present. Okay. Here is the three test tube containing iron steel with three different conditions. Okay. First, test tube containing iron steel, air and water. Second test tube contain water. There is a layer of oil here, so it prevents the air penetrate in. And here is calcium chloride, air but no water. And see that in these two conditions, there's water but no air. The iron does rise. And it same goes if there is air but no water, the iron still not rise. Okay, iron only rise when in the presence of air and water, must in the presence of both oxygen and water. Okay. Rusting process occurs faster in salty water since the presence of sodium chloride. because sodium chloride increases the electrical conductivity of the water, so the reaction becomes faster. The rusting prevention barrier methods. Rust can be prevented by coating iron barriers that prevent the iron from coming into contact with water and oxygen. Okay. However, if the coating are washed away or scratched, the iron is once again exposed to and oxygen and will rust. So this is the common barrier method to prevent rusting. For example, we apply grease and oil, we paint the metal, the iron component, and plastic as a cover. Greenhouse gases, carbon dioxide and methane. What is greenhouse gases? Okay, when short radiation from the sun strike the Earth's surface, it is and re-emitted from the surface of the Earth as infrared radiation. However, much of the infrared energy is trapped inside the Earth's atmosphere by greenhouse gases, which can absorb and hold the radiation. Two such gases are carbon dioxide and methane. They both lead to climate change. They trap heat energy from escaping the Earth's atmosphere, leading to global warming. Okay, this is carbon dioxide and methane, and also known as greenhouse gas. The source of carbon dioxide comes from the combustion of wood and fuel, respiration of plants and animals, and also human, thermal decomposition of carbonate rocks, and the effect of acids on carbonates. Okay, when there's reaction on carbonates, okay, because here is carbonate contains carbon atom, so it will produce carbon dioxide gas. Methane comes from the digestive processes of animals, decomposition of vegetation, bacterial action in swamps, and in rice paddy. The greenhouse effect by the increased concentration and effect on greenhouse gases, methane and carbon dioxide. So the higher the concentration of carbon dioxide and methane, the higher the chance for the greenhouse effect to occur. Okay, this is the consequences of the greenhouse effect. Climate change due to the increase in Earth's temperature. Water level will rise as glaciers melt because of high temperatures, causing flooding in low-lying countries. Extinction of species due to destruction of natural habitats. Migration of species and move to areas that are more habitable. Spread of disease caused by warmer climate. Loss of habitat due to climate change. Animals that live on glaciers will lose their habitat. Carbon cycle. Okay, this is the cycle. The carbon cycle describes the movement of carbon between the land and atmosphere. In the atmosphere, the source of carbon is carbon dioxide. Carbon as carbonate, carbon as carbonate, carbon or organic carbon compound is present in the sea, the air, and the earth. There is a continuous cycle of this compound between this called the carbon cycle. There is a constant amount of carbon compound in the sea, atmosphere, and under the earth. As long as these are balanced, the amount of carbon dioxide in the atmosphere remains constant. Scientists are worried that increasing the amounts of fossil fuel burn will increase global warming and unbalance of the carbon cycle. Okay, sources of carbon dioxide in atmosphere is combustion of fossil fuel. Okay, for example, combustion, respiration, the production of energy in living things, okay, human, animals, and plant. Decomposition of limestone, which contain carbonates. Reaction of acid with carbonates will also produce carbon dioxide. Okay, so how does the carbon dioxide remove from the atmosphere is from the photosynthesis process. Okay, photosynthesis is the process of producing glucose and oxygen from carbon dioxide and water in plants in the presence of chlorophyll and light. That dissolve in the water in seas and ocean and is removed by shellfish for making their calcium carbonate shells. Okay. You can look into the here. Nitrogen and fertilizers. NPK fertilizers. Okay, fertilizers contain nitrogen. N is for nitrogen. P is for potassium. P here is for phosphorus and K here is for potassium. Nitrogen promotes healthy leaf. Potassium promotes growth and healthy fruit and flowers, while phosphorus promotes healthy rocks. Fertilizers compound contain the following water-soluble ions. Okay, the first one is ammonium ions. Ammonium consists of one atom of nitrogen and 4 hydrogen atoms with the positive charge here. And nitro ions consist of one nitrogen atom and 3 oxygen atoms with the negative 1 charge here. Okay, this is the source of soluble nitrogen. Phosphate ions consist of phosphorus atom and 4 oxygen atoms with the negative 3 charge, and it's the source of soluble phosphorus. Most common potassium compound dissolve in water to produce potassium ions, which is K+. Ammonia, manufacture of ammonia. Ammonia is manufactured using the HARBER process, which occurs in 5 stages. So I'm going to look into the 5 stages one by one. Okay. At stage number 1, hydrogen and nitrogen, which obtained from the natural gas in the air, respectively, is into the compressor through pipe. Okay, this is the stage number 2. Here, the gas are compressed to about 200 atmosphere and become, and then is flow into stage number 3, into a chamber at stage number 3. The pressurized gas now pump into a tank containing layers of catalytic iron at a temperature of 150 degrees C. Okay. And this tank use iron as a catalyst and condition temperature at 450 degrees C. Some of the hydrogen and nitrogen react to form ammonia in this stage. Okay. The unreacted hydrogen and nitrogen and product of ammonia pass into cooling tank, and the ammonia is liquefied and removed to pressurized storage vessel here. Okay, so nitrogen and hydrogen gas will react and produce ammonia. Okay, enter this pipe. All right. Unreacted hydrogen and nitrogen gas are recycled back into the system and start over again, while the ammonia will come out as a liquid ammonia. Okay, this is our final product. Okay. So in a process, there are 3 conditions. Here, temperature use 450 degrees C, pressure 200 atm, and catalyst use is iron. Function of catalyst here to speed up the reaction. So that's all for topic of air. Okay, thank you. Have a good day.